Hello friends, we are discussing the fourth unit known as the worm gears, and this is lecture number 1. From this unit, it is expected that the student should learn a skill to design a worm gearbox for various industrial applications. Our syllabus includes the worm and worm gear terminology, then the force analysis of worm gear drive, friction in worm gears, efficiency of worm gears, worm and worm gear material, strength and wear rating of worm gears according to IS 7443, then thermal consideration in worm gear drive, types of failure of worm gear drive, and various methods of lubrication of in worm gear drive. Dealing with the worm gear drive, worm and worm gear drives are used for transmitting the power between two non-intersecting and perpendicular axle shaft. Okay, here in this diagram, this is worm shaft and this is worm, and this is worm wheel or worm gear, you can say. And keep in your mind here, the material used for worm wheel is different than the worm. Please keep in your mind. Why we are studying this worm and worm wheel? Because it has certain advantages over the other gears. Here, worm gear drive is a special purpose gear drive, and it is again very important and rarely used. Now, in this slide, we will deal with the basic of worm and worm gear drive. We already discussed that the worm and worm gear drive are used to transmit the power between two non-intersecting and perpendicular shaft. We know that the spur gear and helical gear need parallel shaft, and bevel gear having a intersecting perpendicular shaft. Okay, but worm and worm gear drive are useful for non-intersecting shaft. Okay, we can transfer the power between two non-intersecting and perpendicular shaft. The worm is generally the driving member, and it is having the trapezoidal and acme thread screw. Okay, and worm gear is similar to that of helical gear, except the face is concave to develop the worm, to envelop the worm, to accumulate the worm. The worm and worm gear drive have same hand of helix, same hand of helix. Worm gear drive are having another feature. The meshing action in the worm gear drive is a combination of sliding and rolling. With sliding is very predominant at higher reduction ratio. Okay, and this sliding, or it is again known as rubbing, because this sliding motion gives the very huge friction, as it is having a line contact or area contact between two mating worm and worm gear. It gives very huge friction. As friction is there, the heat generation is the one thing, and another one, efficiency get reduced. This is another thing. In this slide, we will see the actual gearbox. Okay, actual worm gearbox, and here we can see in first slide the bearing is present. The bearing at both end are present. Then worm gear is present here. Oil seal gearbox is again present. and input shaft worm is present. Ventilator, we know ventilator is very important for the gearbox. Okay, and you can see this is the gearbox, worm gearbox having fins. As we are discussing, we are having a heat generation issue in the worm gearbox. So we will how to dissipate the heat, that is again the issue. So for that one fins can be provided. So this is one of the important aspect while designing industrial worm gearbox. Now practically speaking, worm gearbox is need a huge number of fins, as there is a sliding velocity or rubbing velocity is there. Again, in worm gearbox, the level of lubricating oil is provided such that the worm is dipped into the oil and oil pumped to the thread height. Oil should be pumped up to the thread height. The rotating worm splashes the oil. The rotating worm splashes the oil. If the rotation speed of the worm is low, means if it is less than 750 rpm, the oil splasher is introduced for oil circulation into the gearbox. The quantity of oil used, usually 4 to 6 liter for 1 kilowatt power loss. Keep in your mind the quantity of oil used, usually it is 4 to 6 liter per 1 unit of kilowatt power loss. Adequate lubrication is necessary for satisfactory performance and durability of worm gear pair. Inadequate lubrication contributes toward the scoring failure. Adequate lubrication means the adequate quantity and the quality of lubricant should be made properly circulating inside the gearbox. So while designing the gearbox, the shape should be there, and shape is very important. And again, to dissipate the heat generated inside the worm gearbox, we have to introduce the fins. We will discuss when to introduce the fin and when to introduce a fan. Okay, but keep in your mind at initial case, as there is a very huge heat dissipation is needed in a worm gearbox, so we have to provide fins, and in some cases we have to provide fans for the dissipating the heat. Proper lubrication in the worm gearbox reduces the possibility of scoring failure. Again, it will reduce the wear of teeth. It will reduce the power loss due to friction. It will act as a coolant and dissipate the heat to the surrounding. It will carry out the corresponding warm particles from the gearbox, and it will minimize the noise and vibration and the shock in a gearbox. It will prevent the lubrication. Proper lubrication will prevent the corrosion of the mating surfaces. And the lubricant widely used in worm gears are the straight mineral oil and gear oils. For in the gear oils, various SAE grade gear oils are used. For example, SAE 75W, SAE 80W, SAE 90, SAE 140 and SAE 250 are widely used. While selecting a lubricant, we must select a proper sufficient viscosity of lubricating oil, which will enhance the development of suitable oil film between two the tooth surface and sustain the oil film under the load. This film may be very thin under the boundary lubrication, hence it is necessary to ensure that the lubricant has sufficient oiliness property. Again, oiliness property is very important. Viscosity and the quantity of lubricant is very important in a industrial worm gearbox. Now, in this slide, we will discuss the type of worm used in a worm gear drive. Here, in first one, A, cylindrical or straight worm is shown. Here it is completely straight. There is no concave surface or conical surface. It is again known as a single envelope worm gear. Okay, so sorry, worm only. So, and it is again known as a double enveloping worm, and it is having a conical shape or the concave shape. The single envelope worm gear pair is uh, is thwarted to achieve the various purposes. The single enveloping gear pair has theoretically line contact. Here we will have a line contact between the worm and mating worm wheel, and in double worm gear pair we will have correspondingly surface contact. The double enveloping worm gear pair has theoretically area contact, which increases its load carrying capacity. However, at high speed, more heat generated and hence effective lubrication system is necessary. In addition to this one, the system needs more accurately aligned and mounting. The double enveloping gear pair is difficult to manufacture. This one is very difficult to manufacture, and hence it is not commonly used. While the single or straight worm is widely used as it have easy manufacturing process and line contact, less heat generation comparatively double enveloping worm. Worm gear drive has various advantages, such as the worm gear drives are compact compared with the spur, helical and bevel gear drives for same reduction ratio. It is, as it is a compact and the space savior is again, and very huge, here the reduction ratio can be achieved. The worm gear drive can be used for high reduction ratio. A reduction ratio can be up to 200:1. So within the single pair reduction, single stage reduction. So this is one of the most you can say the important advantage of the worm gear, a high reduction ratio comparatively spur, bevel and the helical, and again it is having operation is very smooth and very silent. The next advantages is that the worm gear drive can be designed for irreversibility or self locking. The if the efficiency of worm gear drive is less than 50%, then the motion can be transmitted only from the worm to the worm gear, and the transmission of the motion from worm gear to worm is not possible. This is very important feature used for the hoisting application. But at the same time, the worm gear drive have various limitations. the efficiency of the worm gear drive is less. We already know that there is a line contact or surface contact, and the sliding or rubbing motion is there. Predominantly sliding is occurring in during the meshing of worm and worm gear. So that rubbing motion or sliding motion gives you very huge friction. As very huge friction, so heat generation is there, power loss is there, and that reduces the efficiency of corresponding gear drive. So the again another one, the considerable amount of frictional heat is generated due to high frictional losses, and hence the effective cooling is necessary for dissipating the heat. The worm geared teeth are normally to be cut on the phosphorus bronze ring, and which again increases the cost. Okay, in first slide I said the material is different. Okay, so here the phosphorus bronze ring is generally used, and that is highly cost. Okay, the power transmission capacity of gear drive is comparatively low. The power transmitting capacity of worm gear drive is comparatively low. So these are the advantages and limitations of worm gear. While the most important advantage is that it is having high reduction ratio, and it is used for the power transmission between two non-intersecting and perpendicular axes. So high reduction ratio is one of the important element or important parameter while designing this corresponding gearbox. These are the three worm gear profiles, rather than profiles, the types. It is a straight face, then hop straight face, and concave face. Again, the manufacturing is easy for the A case, manufacturing is complicated and costly for the C case. Okay. Most important while designing the corresponding worm gear pair, very important thing is the terminology of the worm gear drive. And here the helix angle, lead angle of the worm, then number of start or the threads on the worm, axial pitch of the worm, then transverse pitch of the worm gear, then the normal pitch of the worm gear, then lead of the worm, diametral quotient q is very important, then reduction ratio, center distance, transverse pressure angle, normal pressure angle, addendum, dedendum, face width, and the length of the root of the corresponding worm teeth, and the length of the worm. These are the important terminology, and here you have to know that the screw or input shaft is known as the worm, and while this is known as a worm wheel or worm gear, worm wheel or worm gear. So we will discuss all terminology in next slides. So first, the terminology or nomenclature is the helix angle. Helix angle is an angle made by the helix with an axis of rotation, or it is angle made by the tip with the axis of rotation. A worm and worm gear have same helix angle, same hand of helix, sorry, it is the same hand of helix. So if we are considering helix angle as a psi, so psi w is a helix angle for the worm gear, sorry, worm, and the psi g is the helix angle for the worm gear. And we know that there is a 90-degree angle between the two non-intersecting shafts. So psi w plus psi g is equal to 90 degree. Now next one is the lead angle of the worm, and it is denoted by the corresponding lambda. The lead angle is the angle made by the helix of the worm with the plane perpendicular to the axis of rotation of the worm. In a DME 1, we already know the lead angle of the screw jack. Okay, or you design the power screw. In that one, the lead angle concept, and the same lead angle concept is useful here. The lambda is the lead angle, and lambda is equal to the lead angle of the worm, and it is equal to the psi g. Please keep in your mind, helix angle of the gear is equal to the lead angle of the worm. Then the next one is number of start or the thread on worm. It is denoted by ZW. In VB Bandari book, it is denoted by Z1, and in many books it is denoted by the ZW. So the number of start is the number of thread helices cut around the cylindrical body of the worm along the length of the worm. So ZW. Okay. So while selecting the ZW, we keep our mind that below 7 speed reduction ratio, if we are going for the below 7 speed reduction ratio, the ZW should be 6. If it is in between the reduction ratio, if it is in between 7 to 15, then ZW should be 4. If the reduction ratio is in between 15 to 30, then ZW is 2. And if the high reduction ratio means it is 30 and above, then number of starts ZW should be equal to 1. Generally, the corresponding worm gear pair is designed for the huge reduction ratio more than 30. So ZW generally equal to 1. Now in this slide we will discuss another terminology, axial pitch PA of the worm, then transverse circular pitch of the worm gear PT, then normal circular pitch of the worm gear PN. The axial pitch of the worm is the distance of a point on one teeth to the corresponding point on adjacent tooth, measured on the pitch surface in an axial direction. So it is denoted by PA. Then transverse circular pitch is a circular pitch measured in a transverse plane or a plane of rotation of the gear, of the worm gear. So this PT is equal to PA. PT is equal to PA and is equal to pi into M, where M is a module and M is equal to dg upon zg, where the corresponding transverse module, M is a transverse module in mm, and zg is the pitch circle diameter of the worm gear, and zg is the number of teeth present on the worm gear. Now next definition, we will go for the next definition. The normal circular pitch is the circular pitch measured in a normal plane or the plane perpendicular to the teeth of the worm gear. And again this Pn is equal to Pt into cos of the psi g, and it is again the pi mn, the Pn is a pi mn is equal to pi m into cos of g, means mn is equal to m into cos of psi g. Lead of the worm, again it is the same concept which we already learned in a DME 1 in a power screw. The lead of the worm L is defined as the distance of point on one tooth to the corresponding point on a next tooth on the same helix, measured on the pitch surface in an axial direction. In an axial direction, we know that the relation between lambda and L, tan lambda is equal to L divided by pi into dw, where dw is the corresponding pitch circle diameter of the worm, and generally this lambda is having a value of 9 to 45 degrees. Okay. Now next one is a diametral quotient Q. The diametral quotient is the ratio of pitch circle diameter of worm to the axial module, means Q is equal to the pitch circle of the worm, means dw divided by m, and it is having the range of 6 to 15. But while selecting this diametral quotient, we must know its importance. The body of worm, which is subjected to bending moment and the torque, acts like a shaft with the diameter equal to the addendum pitch circle diameter of the worm. So diametral quotient Q determines the moment of resistance of the worm against the bending and torsional. If we are having larger Q, the worm diameter is larger. If we are selecting Q as a larger, then the worm diameter will be larger. Hence, the strength and rigidity of worm shaft will be higher. But at the same time, with the Q is larger, the lead angle lambda is smaller. Hence, efficiency will get reduced. And if we are selecting the smaller Q, then the angle lambda is larger, efficiency will be high for the smaller Q, but the strength get reduced and shaft become weaker. So in practice, the diametral quotient Q is generally taken between the 6 to 15, and for normal design an average value of Q is taken as a 10. So Q is generally taken as a 10. Next one is the very important face width. Face width is having the same concept which we are using in the spur or helical or bevel. Okay. So here the face width B is should be greater than or equal to 2 module into square root of Q plus 1 or 0.73 dW, whichever larger we will select. Okay. So keep in your mind the face width is not 10 times of the module. Here face width is having a different value, and the value is a comparison between two. It is 2 module into square root of Q plus 1 or 0.73 into W, what may be the larger value, we have to select the larger value for the B. And in transverse module M, we must know that there are two choices are recommended by ISO in mm. So standard module, first choice is 1, 1.25, 1.5, 2, 2.5, 3, 4, 5, 6, 8, 10, 12, 16, 20, 25, 32, 40 and 50. And the second choice is again prescribed as 1.125, 1.375, 1.75, 2.5, 2.75, 3.5, 4.5, 5.5, 7, 9, 11, 14, 18, 22, 28, then 36 and 45. So these are the recommended module by the ISO in mm. And while designing, we will go through the first choice initially, then second choice is generally not preferable here, and our syllabus is designed such that the second choice is not used in the numericals. And within this terminology, addendum and dedendum has to be discussed. The addendum can be say as a one module, and dedendum is can be say 1.25 module for lambda is less than 15 degree. The lead angle lambda is less than 15 degree. At that time, the dedendum can be 1.2 module. And correspondingly, if we are going for the addendum and dedendum, if lambda is greater than 15, then the addendum is equal to 1 normal module, 1 normal module, and dedendum is equal to 1.2 normal module. The difference is in first case where less than 15 degree, when the lambda is less than 15 degree, at that time it is 1 into module, transverse module. So 1 into module or and HF is equal to 1.2 module. And in different another case, lambda is greater than 15 degree, lead angle is greater than 15 degree. At that time, the HA addendum is 1 into normal module, not a simple module, it's a normal, Mn is considered, and HF is equal to 1.2 normal module, Mn. Okay, so while addendum and dedendum, this is the change for comparatively other gear pairs. Again, standard pressure angle, standard normal pressure angles are here. It is described as a 14.5 degree, 20 degree, 22.5 degree, 25 degree and 30 degree. And at the time of selection of this normal pressure angle phi n, when the lambda is less than 15 degree, at that time less than 15 degree, at that time the normal pressure angle can be taken as a 14.5 degree. And if it is the lambda lead angle is in between 15 to 30 degree, at that time normal pressure angle should be taken as a 20 degree. If the lead angle lambda is in between 30 degree to 40 degree, at that time normal pressure angle phi n has to be taken as a 25 degree. Okay, and if it is the lead angle lambda is in between 40 to 45 degree, at that time normal pressure angle phi n can be considered as a 30 degree. And 22.5 degree is not generally preferred. Please keep in your mind, it is not generally preferred. And again another concept is the center distance. We know that in previous um, corresponding units we already know the center distance. It is the shortest distance between the axis of worm and worm gear, and it is the radius plus radius. Radius, the corresponding the pitch circle diameter of the worm divided by 2 plus the PCD of the gear divided by 2. So the center distance we can calculate according to the uh, we can say module into Q plus module into ZG divided by 2, and we can take module as a common. Hence the center distance can be calculated. In next slide we will go for the designation of worm and worm gear pair. So designation is the, you can say, method to specify the corresponding gear pair. As we already know, we are knowing the designation or of bearing or bearing number. Okay, same kind of designation is available for the for the worm gear pair. Keep in your mind the designation is very important in a design and the specification of the corresponding worm gear pair. And selection of this corresponding worm gear pair uh, number or designation can be taken from the standard tables. So here is the slide of designation of worm and worm gear pair. So the designation is like this: some number oblique the another number oblique then the number oblique and then again a number. So first number in a designation indicates the ZW. So it is ZW, the sequence is ZW, then next ZG, then next Q, then M. So ZW is the number of start on a worm, number of threads on a worm, so ZW. Then next one is a ZG. So ZG is the number of teeth on a worm gear. Then Q is the diametral quotient and M is the module in mm. And this table indicates how this correspondingly is shown. In VB Bandari, I already said the number of start is known as a Z1. Then ZG is known as a Z2. Then Q and M. This is the standard table for approximate transmission ratio 20, 25, 30, 40, 50, and the corresponding center distance. Various options are shown to us. This table is again taken from the BB Bandari book, and this is the designation. And in sometimes again additional to this one means ZW, then ZG, then Q, then M, then oblique A means center distance can be specified. In some of the specific cases it is discussed. So how to designate it? ZW oblique ZG oblique Q oblique M, and in some cases it last one oblique A means center distance can be added. Okay. So Q is a diameter quotient and it is very important, and it should be taken in between 6 to 15, and here you can see the Q is generally taken as a 10, for almost all center distance. Means for all option within this table you can see diametral quotient Q is preferred as a 10. Keep in your mind. For this lecture we can say we started with the introduction, then advantages, disadvantages, terminology and designation of the worm gear pair. From my end, this lecture is over. If you have any query, question, difficulties, please contact me on my WhatsApp. Thank you. Thank you everyone. Stay safe, stay at home. We have to fight this COVID-19 as early as possible. Thank you everyone.